everyone. My name is Cassidy. Today we've launched Gemma 3. This is the latest addition to our family of open source models. These are our most capable, portable, and responsible models yet. Last week, we ran an early preview of Gemma 3 27B IT on the LMSys chatbot arena. And we are excited to announce that Gemma 3 27B IT ranks in the top 10 models on LMSys. This is significantly outperforming models over 15 times its size and truly setting a new frontier for open, on-device, small models. It's an honor to be standing in front of you all today, introducing Gemma 3 and sharing the exciting performance achievements that we've worked on for the last several months. The Gemma 3 family of models is designed for the everyday developer. This is something which should be easily accessible to each and every one of you. The Gemma 3 family of models comes in 4 different sizes. Our 1B is a lightweight text model, which is ideal for small applications. Our 4B balances flexibility and performance with additional multimodal support. Our 12B has strong language capabilities and is designed for more complex tasks. And last but not least, our 27B. This is our most sophisticated model yet, offering a significantly expanded capacity for handling intricate tasks and delivers an elevated level of performance for demanding applications. For each of these models, we have released both pre- and post-train checkpoints. For each of these checkpoints, we have released 4 different versions, quantized for bfloat 16, float 8, int4, and q40. The Gemma 1B is the smallest model of the Gemma family. This is geared towards on-device use cases, which is supported by having less than a 700M memory footprint when quantized for q40. This is a text-only model which specializes in English and multilingual performance while still having impressive STEM performance. This is a 32K context length model, which is a significant improvement from the Gemma 2 family of 8K context length. We have several other big advancements with the Gemma 3 family, specifically 4 big tech improvements. Across our 4B, 12B, and 27B models, we have a 16 times longer context length, now supporting 128K tokens. We have expanded multilinguality, where Gemma 3 now supports over 140 different languages. Gemma 3 is a multimodal model with interleaved image and text on input, while maintaining being a text-only output model. Lastly, we have also added support for function calling. This allows you to create a natural language interface for a programming API without needing to write any code. This allows you to generate programming calls as part of an AI agent workflow. Through this programming interface, you can control the model behavior and output. It would be impossible to stand on this stage today in Paris announcing Gemma 3 without highlighting the significant advancements that we've made for multilinguality. Across pre- and post-training, we have over doubled the amount of multilingual data which we are training on. This has been made possible by using a Unimax sampling distribution in selecting the languages which we are training on. This has allowed Gemma 3 to represent over 140 different languages. And now, one of the exciting things with Gemma 3 is our ability to be multimodal natively. Gemma 3 supports interleaving text and images on input, while Gemma will output text. This has been made possible by our Vision encoder, which is a SIGLIP variant which has been tailored to our specific needs. Later today, Aishwarya and Geoffrey will share more on the multimodal capabilities of Gemma and what you can build with this. But right now, I'm excited to introduce Shreya, who will share more on the architecture of Gemma pre-training and how you guys can get started with all of this. Thank you.
Hi, I'm Shreya. I'm a research engineer on the Gemma team. Like the previous versions, we are releasing pre-trained checkpoints for all sizes of the Gemma 3 family. We have updated models in the 3 size categories from Gemma 2. For all of them, we maintain or improve performance on text metrics across different capabilities like code, math, reasoning, factuality, and multilinguality. The V3 improvements over V2 are shown in red in the slides. In addition, we introduce a new size range, the 1B model, which is great for resource-constrained users and demonstrates excellent English and multilingual performance. Our pre-training recipe remains similar to Gemma 2 with some updates to aid the new capabilities that we are adding. We upgrade to a new tokenizer specifically aimed at improving multilingual performance. Our 4, 12, and 27B models are multimodal from scratch, trained with the frozen vision encoder. So, the model can understand and answer questions about a variety of images, ranging from natural images to pictures of documents and charts. Gemma 3 can support 4 times larger queries. Gemma 2 was trained at 8K context length. In contrast, Gemma 3 is trained at 32K from the start. In the final stages of training, we further extend the context length, allowing the model to support up to 128K tokens, opening up so many possibilities. With the long context capability, we can now pass in several pages worth of documents and images to the model and perform different tasks on it, like summarization, retrieval, and question answering. Now let's see what architecture improvements are needed for this. In Gemma 2, we had introduced interleaved attention in our model, alternating between local and global layers. The local layers had a sliding window of length 4096, meaning that every token attended to this many tokens that occurred before it. For Gemma 3, we update the attention pattern and have 5 local layers for every global layer. So, starting from the first layer, we have 5 local layers, followed by 1 global layer, and so on. Further, we update the sliding window size to 1024 and decrease it even further to 512 for our smallest 1B model. These updates greatly reduce our memory footprint at inference time by decreasing the size of the KV cache. So, we can use the model at longer context lengths without facing a significant increase in memory requirements. Like the previous versions, our models continue to use rope position embeddings. To improve performance at longer context lengths, we update the rope config that we use. The frequency for the global layers is increased to 1 million, while keeping it the same at 10,000 for the local layers. In the final phase of training, we rescale the rope embeddings with a factor of 8, helping the model generalize to longer sequence lengths. To test out the model, I collected some snippets from my favorite books and passed it to the instruction-tuned Gemma 327B model, and then proceeded to ask some questions. The snippets were from classic books like Little Women, Pride and Prejudice, A Tale of Two Cities, A Christmas Carol, and more. The first question was a simple one, asking the model to give the time when the 4th snippet takes place and what the name of the main character was. The text was from A Christmas Carol, and the model is able to correctly answer the asked question. Note that to figure out which book is the 4th, the model has to really get what the text is saying. It cannot answer this question without attending to the text. Then I give it a bit more nuanced question, asking it to give 3 citations from the text describing Beth's nature. The question is about the book Little Women. The model is able to correctly identify which book this question pertains to, and is then able to get examples and their interpretations. Basically, the model knows where to look at in a big chunk of text, so it can understand and answer all sorts of questions. Next up, Leo will talk about post-training in Gemma 3.
Hi, everyone. My name is Léonard Hussenot. I'm a research scientist in Google DeepMind, and I work in the post-training team of Gemma. And for those who don't know, that's how I like to think about the difference between pre-training and post-training. Pre-training is about encompassing and compressing the whole world's information, right? It trains on a massive amount of data, you know all of that, right? Post-training is more about shaping the model's behavior for all capabilities, for all abilities. It's about picking its behavior, its personality in some sense. And for Gemma 3, I can tell you we made sure this behavior is good on a really wide set of tasks. You have here like the comparison of Gemma 2 and Gemma 3 equivalent sizes on a wide set of tasks, code, chat, math. And as you can see, like our new 4B outperforms by far the previous 2B, 12 outperforms by far the previous 9, and 27 by far the 27. And I can even tell you that somehow our Gemma 3 4B is almost on par with Gemma 2 27B, making it already a very, very good model at the 4B size. And of course, if this is the case, you can extrapolate our 27B is extremely good too. And these benchmark numbers also translate in how our users and how developers actually like the model. And Tris already said it, and Cassidy repeated it, but it's quite an amazing number you have here. Actually, we gained 1 more point of ELO last night, so it's now 1339. Really important. Yes, please. Round of applause. Maybe just to put this into context, the only open model above us on the LM6 arena is a 671 billion mixture of experts, right? That's with thinking enabled, right? Because with disabled, we're also on top of it. So, it's an impressive result. I really can't wait to see where the 12B, the 4B and 1B will land. We don't know. We're waiting for it, just like you. But the same recipe was applied, and we're pretty confident it will be also really nice trade-offs with these smaller models. To get the most of these models, I'm going to come up with a couple of advice on how to use them. Pre-training models, pretty easy, right? They do next token prediction. You sample, you start with beginning of sequence token, and you stop sampling when it gets to the end of sequence token. Quite classical. With instruction-tuned models, there's a bit more work there. You just need to use the correct formatting sequence, right? And you have everything in the tech report, but just so you remind this is a kind of formatted discussion. You don't forget also the beginning of sequence token, and then you have these turn markers between the user turn and the model turn. And you stop sampling when you hit the end of turn and not the end of sequence token. So slight difference when using, and when I mean using either sampling from it or even fine-tuning it, you have to adapt to whether you're using a pre-trained model or an IT model. All details are in the technical report, so please refer to that when trying to use these models. Maybe last is a bit more on the prompting itself. We really tuned these instruction-tuned models to be good on a wide variety of tasks. We really looked at tons of metrics. The team spent hours vibe-checking the models on a super large set of abilities. So, just be specific when you want something specific. If you only want Python code, just say only output Python code, right? If you want only yes or no, just answer the following questions by yes or no, right? Just be as specific as possible, and you'll see that Gemma 3 is much stronger than Gemma 2 at instruction following overall, be it for respecting JSON formatting or whatever you developers want to use Gemma for. If you're interested in system instructions, there's no special formatting for them. Just put them in the first user prompt, and Gemma, we made sure that Gemma will follow the system instructions throughout the turns of the discussions. And it has been mentioned to you before, but Gemma 3 has a much longer context length than Gemma 2, and you should make the most of it because in post-training we also made sure that Gemma is really good along a very long set of turns. So don't hesitate to rely on the multi-turn abilities of Gemma 3, right? It's really good with that. Thank you very much, and I let the stage for Aish.
Morning, everyone. I'm Aishwarya Kamath. I'm a research scientist on the Gemma team. Previous versions of Gemma, like Gemma 1 and Gemma 2, were text-only, so as some of you may know, the PalyGemma team worked on patching in multimodal support after the fact. Gemma 3, that we just launched today, expands its capabilities to include vision understanding from the start while simultaneously preserving or enhancing performance across a broad range of text skills such as code generation, factuality, reasoning, math, and multilingual processing. To start, I'd like to highlight some differences between the previous generation of multimodal models built using Gemma and the new natively multimodal Gemma 3. The first is that PalyGemma provides a separate model for 3 input resolutions. On the other hand, Gemma is one model that supports any resolution. PalyGemma models are geared towards task transfer through fine-tuning on specific examples. Gemma 3, on the other hand, is great at zero-shot performance and can be used out of the box on a wider variety of tasks without fine-tuning on the specific examples. PalyGemma is also not instruction-tuned, while Gemma 3 models are. What this means is that the model is able to better understand user intent, leading to responses that are more accurate and relevant. PalyGemma also does not support fully interleaved image and text, while Gemma 3 does. This enables more natural interactions through multimodal chat using everyday language, and this makes the experience more user-friendly. In case you are interested in fine-tuning on downstream tasks, Gemma 3 pre-trained checkpoints are a great base model. The 4B model is 10 times cheaper to transfer while outperforming the larger size PalyGemma models on high-resolution tasks. This is thanks to the more efficient image encoding used in Gemma 3. At this point, I'd just like to remind you that all of these expanded capabilities do not come at the expense of text performance. And you've seen the ELO scores already, so it's pretty cool that we can achieve all of this extra stuff without hurting text. So now that we've seen what the model can do, let's take a look at how we do it. Here's an example of how multimodal inputs are processed by Gemma 3. In this example, we have an image of a sea otter out shopping in a mall and a prompt asking to describe the image. The image is square resized to 896 by 896 resolution, and our vision encoder, which is a SIGLEP variant, processes the image to produce visual tokens. These are then average pooled to produce 256 tokens per image. The image tokens are flattened and passed to Gemma 3 along with the text prompt to produce the output in an autoregressive manner. We follow up asking Gemma to read the calculator held up in the image, and Gemma, with its excellent OCR capabilities, provides us with an answer. Here I've illustrated the attention pattern used in Gemma 3 to support interleaved image and text. The attention is fully causal on text and bidirectional on images. We evaluate Gemma 3 on a wide range of domains, and as you can see here, Gemma 3 achieves great performance on reasoning, math, document understanding, and video understanding, often outperforming or matching models that are much larger in size. While square resize suffices for most images seen in the wild, as you can see here, it severely limits readability for images that have skewed aspect ratios. We use the following approach to process such images. We pan over the image and extract crops. Each crop is then resized to standard input resolution and fed to the model. Minimum crop size and number of crops are configurable and decides how much the model can zoom into the image. With this approach, we are able to train at a single resolution and evaluate at any resolution. While Gemma 3 already has impressive performance on many image understanding benchmarks, Pan and Scan allows us to effectively handle images with varying aspect ratios, providing boosts on document-related tasks or tasks that involve reading text and reasoning on images. Gemma 3's multimodal chat capabilities, combined with its multilingual proficiency, better reasoning and math abilities, and a 128K context length, paves the way for a multitude of diverse and innovative applications. Geoffrey, who will be presenting next, will go more in depth with a few examples bringing all of these capabilities together. Thank you.
Hi, everyone. I'm Geoffrey Cideron. I'm a research engineer at Google DeepMind, where I work on the post-training of Gemma. For this new generation of Gemma models, we added image prompts in our instruction tuning recipe in order to make Gemma 3 IT a ready-to-use multimodal generalist model. Now, we can have back-and-forth conversations with Gemma using images. So let's dive into a few examples to explore what we can do with Gemma. First one is like a reasoning example. So we drew in a whiteboard a rectangle where we added some measurements and also a question mark. And we asked Gemma, what is the question mark in the image? Gemma understood our hidden intent, which was to compute the value of the diagonal and proceed by computing it. Then we have a cool use case where we want to go from images to LaTeX formula. So we took a screenshot of a math equation, and we asked Gemma, can you transcribe this equation into LaTeX formula? This was easy work for Gemma, and which outputted the LaTeX formula, plus some nice explanations of the math formula. Then we wanted to try multi-turn and also multilinguality. So we took a picture of a bus ticket from Prague, and we asked Gemma, how much is this ticket? Gemma understood that the ticket cost 870 Czech kroner. So then we ask another question. How long is this ticket valid? So Gemma understood that on the top left corner of the bus ticket, you had like a clock sign with a 24-hour next to it, and it made the guess that that this sign would mean that the ticket would be valid for 24 hours, which was indeed the case. Then for our last example, we have a simple plot with two functions, and we ask a bunch of questions to Gemma. First one, pretty simple. What is G? So Gemma understood that G is the horizontal line at y equals to 1. Then, a bit more tricky question, what about F? So here, you have to make some guesses by looking at how the curve behaves. And actually, Gemma made the right guess that F is ln x plus 1 minus 1, and then gave some explanations on why it decided to choose this approximation. Then we asked, at what point would this function cross? Gemma relied on past context to understand what we were talking about and started to solve the equation needed to answer this question. Then maybe a pressing question for us, what about the derivative of f? So Gemma already computed f, so now it just proceeds by computing the derivative of f without needing to retrieve what is f. And then, last thing, we wanted to make sure that Gemma didn't forget about the image we gave at the very beginning of our exchange. And so we asked, what is the color of G? It was easy work for Gemma as well, as it found the right answer, orange. So these 4 examples are just a tiny sample of what we can do with Gemma. We are really excited to release Gemma to the public and see all the cool use cases you will come up with. Thanks, and now I'd like to welcome Robert.
Hey everyone, my name is Robert Dadashi. I'm a research scientist in the Gemma team. So Google's mission is to organize the world's information and make it universally accessible and useful. And the Gemma models are completely aligned with this mission. They're small, they can run on device, they're open weights, and they're extremely capable. It's still our responsibility to make sure they're widely accessible by making them really good at multilingual. So for Gemma 1 and Gemma 2, we already have pretty strong multilingual abilities, but we still decided to literally double down on the weight of multilingual data for both pre-training and post-training. We also updated the tokenizer, because a large language model can only be as good as its underlying tokenizer. And during development, we set ourselves a high bar on multilingual evals. Speaking of post-training evals, they're usually based on side-by-side evaluations. So you take a set of prompts of a specific language. You generate one answer for Gemma and one answer from a baseline model. And then you ask a usually bigger and more capable model to give a preference score between the two answers. So usually it goes from negative 1.5 to positive 1.5, where the negative number means that you prefer the baseline and the positive number means that you prefer Gemma. Here are some numbers. Here we compare Gemma 2 27B to GPT-4o and Gemma 3 27B to GPT-4o. For you to understand what these numbers mean, we usually consider that plus 0.05 is a significant improvement. And we see that for German, we go all the way to plus 0.25 compared to GPT-4o. In Spanish, plus 0.22. And in Japanese, plus 0.03. In fact, 1 minute before this talk, I just learned that on the LM6 chatbot arena, the Gemma 3 27B model is now leading all open weights model in French and in Spanish. Now we're in French, so we speak French. Here's an example that I really like. It's personal. Je suis né dans les années 90 en France, je suis un fan de football. À ton avis, qui est le héros de ma jeunesse? Réponds uniquement avec son surnom et son numéro avec un tiret entre les deux. What this means is that I was born in the 90s in France. I'm a football fan. According to you, who's my childhood hero? Answer by giving his nickname and his number with a hyphen between the two. Obviously, the answer is Zizou 10. Now, the reason why I really like this example is that, first of all, the model needs to understand French. Then it needs to have some cultural context, right? It needs to know what happened in the 90s in France, which has a link with football, the World Cup 98. It needs to know what was the most popular player on the team, Zinedine Zidane. It needs to know what was his number 10. And then it needs to understand the formatting requirement of this prompt, which is to output his nickname with a hyphen between his nickname and his number. Now, with this great example, I'd like to thank you. Oh, wait, sorry, there's this slide as well. So we know that Gemma 3 is pretty great, but it's really our mission to make it even better at multilingual abilities. It's one thing to serve 140 languages, but there's still so much more that we can do to improve Gemma. Now, I'd like to thank you all for your attendance. We're, on behalf of my teammate, we're so excited to see what amazing things you will build with this new generation of Gemma models.